Here's the problem coming from tangent and normal, that is from calculus. The curve is y is equal to x upon x square minus 3 and the tangent at the point alpha comma beta is parallel to this line, that is 2x plus 6y minus 11 is equal to 0. Definitely the slope of the tangent is given to us and we want to find out the coordinate alpha and beta which are lying on this curve. So definitely first what we have to do, we have to satisfy that particular point which is lying. So from here we will be having the first equation. Now the slope is given to us, that is equal to minus 1 by 3. So we need to differentiate this. So I am differentiating this curve, that is dy by dx is equal to, applying the division rule here, what we will be having is in the denominator x square minus 3 whole square, and the numerator it is 1 into x square minus 3 minus 2x, the derivative is 2x into x. So this comes out to be minus x square minus 3 upon x square minus 3 whole square. Now the slope at the point alpha comma beta is given to us. So what we are going to do here is, by putting alpha here, the slope in terms of alpha is this one, which is equal to slope of this line, that is equal to minus 1 by 3. Now you can notice here this is a quadratic in alpha square. So this can be easily evaluated. So from here alpha square is equal to 9. So alpha is definitely equal to plus minus 3, and by putting alpha here in this equation you will get beta is equal to plus minus 1 by 2. Now substituting in these options, you will see this is the option which will be satisfying these values, that is alpha plus minus 3 and beta equal to plus minus 1 by 2. So first is the correct option. So this is the next problem on the differential equation. Again a linear differential equation which is very well known to us. Dy by dx y into tan x, this is function p, and this is q again in terms of x. So it is involving an integrating factor for us. So first we need to find out the integrating factor here, which is equal to e raised to the power integral of tan x. So this is the integrating factor, which is equal to e raised to the power ln secant x. So this comes out to be secant x. You know it well. Now we know the result. It is y into integrating factor is equal to integral of integrating factor, that is secant x, into the function q, that is 2x plus x square into tan x. So we need to find out the integral of this one. So let us see what is the integral of this one. If you split this up, you can see this is x square tan x secant x plus 2x secant x. Now applying by parts on this part, the integral of tan x secant x is definitely secant x into x square minus, differentiating this, 2x into secant x. Now you can easily see this will cancel out with the remaining part. So here we can see the cancellation here. So we have integration x square secant x plus an integration factor integrating the integration constant, this is c. Now it is given that the value at x equal to 0 is equal to 1. So by putting x equal to 0 you can notice here this will become 0, this will become 1. So, y is also given to be 1. So, this is 1, 1 is equal to 0 plus c. So, c is definitely equal to 1. So, what is the function we are having here? Dividing with secant x, we have y is equal to x square plus 1 into cos x. So, this is the function for us. Now, you can check the various options which are given to us, the value at pi by 4 and minus pi by 4, that will come out to be same. So, this one is not the correct option, that is a different value. Again, you can check the derivative as well at different options. If you differentiate the function and you calculate the value at pi by 4 and minus pi by 4, you can see the correct option is the fourth one, that is the derivative of the function at pi by 4 and again at minus pi by 4. The difference is coming out to be pi minus root 2. Let us see the next problem. Here's a question again from sequence and series. It is given that the sixth term of this AP is 2 and the common difference of this AP we have to find out such that the product of these three terms, that is the first, fourth and fifth term, is maximum. So, we have to maximize this product. So, assuming this function or creating this function in a single variable is important. So, let us assume this A is the variable here, which is the product of A1, A4 and A5. Now, D is the variable, D is the common difference. What is given to us is the sixth term. So, let us assume that the first term of this AP is A. So, the sixth term which is given is A plus 5D. Now, you can see this A which is to be maximized, the first term is A. So, straight away this A can be written in terms of D. A plus 5D is the sixth term which is equal to 2. So, if you calculate this, this will be 2 minus 5D. And similarly, the fourth term A4 which is equal to A plus 3D. Now, you know what is A in terms of D, you can calculate this as well, which will come out to be 2 minus 2D, and similarly fifth A5 will be A plus 4D, and that too can be calculated with the help of this result in terms of D, and that comes out to be 2 minus D. So, the product of these three terms, which is again in the single variable D, is to be maximized. So, we need to differentiate this. If you differentiate this with respect to D by applying the product rule, here we have minus 5 whole into 2 minus 2D into 2 minus D, again plus 2 minus 5D, differentiating the second term, this will be minus 2, 2 minus D, again the third term, that is this one, this is 2 minus 5D into 2 minus 2D into minus 1. Now, equating this to 0. For maxima, we need to find out the critical points. We will get two critical points from here. 1D will be equal to 8 by 5 and next will be equal to 2 by 3. Now, there are two critical points and we need to check where the value will become maximum. So, what we need to do, we will again differentiate this function, that is the double derivative test we are going to do here. If you again differentiate this function and at 2 by 3, if you check at 2 by 3, you will see this second derivative will be less than 0. So, if the second derivative is lesser than 0, we know that this is the point of maxima. So, at maximum D is equal to 2 by 3. So, this is going to be the correct option. You can notice here there is one more option, 8 by 5. So, we need to check it before coming to the final answer. we need to check where you will get the maximum value of the A1, A4 and A5. Let's move to the next problem.